We start with a screen called the Downtime Administration System. From here, you can filter, sort, and search through the entire active work orders. The column of interest is the one labeled LRCM. When a work order is to be populated with vital reliability analysis enabling information, the technician or supervisor will select the LRCM icon for the work order in question. I'll point out before clicking on the tree icon in the LRCM column that this screen is synchronized in real time with the CMMS or EAM, be it SAP, Maximo, or Ellipse. Clicking on the LRCM icon brings up the knowledge tree for the equipment that the work order addresses. This novel way of populating a work order ensures that two essential activities take place. First, that the failure mode, consisting of the object part, object damage, and failure cause, are attributed to the work order with absolute accuracy and no ambiguity whatsoever. Secondly, that any divergence between the documented knowledge in the tree and the actual field observations will be corrected both in the knowledge base and in the catalogs. This knowledge feedback process will be performed simply, systematically, and in a controlled manner. In a moment, we'll perform the first of these actions. We'll use the keyword search, or we can drill down manually to an object part that was renewed in the scope of the execution of this work order. By definition, the technician zero times an object part or failure mode. That is to say, he resets the failure mode's age to 0. This is a basic concept in achieving our objective of reliability analysis and practical decision modeling. By definition, a failure mode is the grammatical combination of object part, object damage, and failure cause. Before making our selection, note that when you hover over the failure mode leaf in the tree, a tooltip appears. It displays the documented knowledge of the failure effects, the mitigating maintenance activity currently in place, and the consequences. The tooltip is the first line of defense against selecting the wrong failure mode. When you are sure that you are about to select the right failure mode, click on the asterisk. A dialog pops up that requires you to select an event type. The event type answers the question, how did this failure mode, being renewed on the current work order, end its life? Was it a functional failure, a potential failure, or was this a discretionary preventive renewal, which we call a suspension? This is absolute essential information without which reliability analysis cannot be performed. Let's select functional failure. Functional failure means that the organization has incurred dire consequences of the failure. Had we selected potential failure, it would have meant that we caught the failure mode in progress, perhaps due to a programmed inspection or having received a condition indicator signal, thereby avoiding or mitigating the direst consequences of failure. Once you accept the event type, the failure mode appears in a table located above the tree. If you open the table, you will see the information associated with the selected failure mode, particularly the effects of failure as they have been documented in the knowledge base. This is the second line of defense against selecting an incorrect failure mode. If you change your mind, simply hit the red bin and select the right failure mode in the tree. you can hit the image gallery icon. This will display the complete set of information on the failure mode, including any images that are necessary to describe the effects of failure. The most important role of the image gallery associated with a failure mode is to establish standards for distinguishing suspensions from potential failures. For example, one technician might consider a moderately frayed hose as having potentially failed, since it has not yet sprung a leak. But another tech might say that the replaced object part has been suspended. By definition, a suspension is a renewal of a failure mode that has an indeterminate amount of useful life left. Given that this is a subjective call, the images help the organization to develop standards for discriminating failure from suspension. Why is this important? Because reporting suspensions as failures will diminish the performance of your predictive decision model. Hit the feedback button. Add a description that will become the image's caption. Now you have the choice of selecting an image file or snapping a picture if you are using a mobile tablet or smartphone. Note that even if you are out of wireless range, all transactions are stored on the device and executed once you are back in range. Finally, you can add any additional comments needed to explain why you are suggesting that this image be added to the gallery for this failure mode. Examine the feedback table and note that your feedback image is duly pending. You can also send a purely textual feedback. Hit the balloon icon and choose an operation. Either modify, add, or delete a node. If you want to add a new failure mode, that is, a new combination of object part, object damage, and failure cause, you can search for it in the catalog list. If it is not there, you can suggest a new one. You would propose a description and add a justification if needed for the catalog update request. Your feedback appears in a second table above the equipment knowledge tree. Note again that this proposed knowledge update is pending. In a few minutes, we'll see how these suggestions are processed in the Feedback Manager. To summarize, we have selected one or more failure modes on this work order, and we have attributed their event types. Then we demonstrated how to feed back important knowledge from the field in order for continuous knowledge improvement. Now let's switch to the second and final form to be demonstrated today, namely the Feedback Manager. In this form, we see the list of pending knowledge update suggestions. This form is used weekly by a committee responsible for reliability engineering knowledge quality and updating the maintenance strategy accordingly. Select one of the operations and the equipment knowledge tree opens, highlighting the node where the modification, insertion, or deletion is to take place. We click on the Edit Feedback button in order to examine the recommendation and decide if and how it should be incorporated into the knowledge base. The dialog opens and allows editing of the changes to the node. Incidentally, all approved changes are retained in an audit trail. That means we can go back and see what was the state of our knowledge at any previous point in time. The audit trail is especially valuable in root cause failure investigations, when we would like to trace what was known about the failure mode and what consequence mitigating strategy was in place prior to the incident. There is a second feature related to safety and the environment. Recall that the LRCM process records instances of potential failures. It is well known that most serious accidents are preceded by a number of foretelling incidents whose consequences were minor at the time. The LRCM system will expose such repetitive minor instances. Their safety implications will have been documented in the failure effects field of the knowledge tree. Finally, we can hit the Update Failure Mode button and review the complete failure mode information. In a similar manner to the review and approval of textual feedbacks, we can also examine any pending image suggestions and approve them for addition to the gallery associated with a given failure mode. Thank you for watching.